Hello. Lots of stuff here left unmodeled, but I think that it'll give us a pretty clear direction until we talk again. Let's start with the fact that I modeled the hard way of doing it, right? This made me comfortable with saying we could build an entirely pneumatic machine because I have a backup plan, right? Um, I'm 100% confident in the ability of this sled to pull that remnant off because I can put, I mean, however much tonnage that you need, I'm going to use the axle as the structural member. So that made the frame a whole lot smaller. It made the cylinders a whole lot less stroke. It did a lot of things that I felt like if I was unsuccessful with the push method that I proposed the first time around, if I went back to try to fix that problem, it would have been in a whole nother budget. Um, Much larger cylinder, and we would have had to use recirculation. It was a nightmare. But with this, I can put a tiny little inner pack. For the purposes of modeling it, I used a 150 ton 5/8 stroke inner pack. And that's all I really need is to push this sled over the remnant, let these fold out of the way, and then activate that inner pack, push off of this cup, right? Right there, would push off of right there. And that's going to pull that over the remnant with 150 tons of force, and it's not going to cost me a ton more than the pneumatic method. Now, for the pneumatic method, I wanted to basically flip these around and make them one piece. There is a significant chance that we can use this plate for the Hansa and pull off of that, so that when the Hansa is activated, we can shove these over the remnant from the front. And because we're doing it with a cable, which again, I modeled the cylinder, but I didn't model the cable mechanism. But basically, as the cylinder extends, we're going to pull some cables in here. Because we're doing it with a cable, I don't have to clamp the axle because these two sleds would move at an identical pace. So whether the axle moves left to right for a small time doesn't really matter. In the end, when the things finish their stroke, it's going to be centered. Some other things I wanted to mention. I like using three legs for machinery. They still need to be leveled, of course, but at least when you sit them down, they're not rocking back and forth. So I think the final version of this will probably be much wider because the cylinders stick out so far. And this sled, which is pretty heavy, the drill tap sled, it comes back so far. I've got limits set up, so that's how far back that I want it to come, and I'll talk about the reason for that next. But the weight of it concerns me, so I could see myself making this much wider. When I quoted the enclosure price, I planned on an 8 by 12 enclosure that was 8 feet tall, and that was because the cylinders are poking out and the sled pokes out. So the reason I have the sled moving so far is that I'm using the sled as the ejection mechanism. And again, I didn't model that, but I think you guys will get the hint. There's room on the outside of this plate for a ramp, and I want the ramp to lift the axle, and then at the end of the ramp, I'll have a stop that pushes the axle off and onto the current rolling conveyor that you guys have now. Then upon a new cycle, when the sled comes back in, that stop will have to be on a pivot, and it will fold forward to get underneath the axle, right? So I'm trying to eliminate as much of the I/O and the complexity of the program as possible. So I really only have 3 or 4 motions here. Well, it's 3 motions and 4 things to trigger because I have to have a 2-speed motor for the drilling and tapping. Hopefully that gets you a pretty clear picture of what I'm trying to do. I did model for the purposes of, see, I didn't model the ramps because I already know that I'm buying a 4x8 sheet of 1-inch steel, and so the cost of those ramps is not a problem. The cost is here in like these little guys. So I want to be able to adjust, upon the initial setup of this machine, we're going to have to put an axle in there. And then I want to be able to put the axle in manually, let it center itself, and then come in with these blocks on some slide plates and let them touch the axle so we can center everything correctly. Stuff like that is why I modeled it for the bid. Let me know if you have any other questions, and I'm going to have a link to this so you can actually manipulate the model yourself as well. And hopefully I didn't miss anything, but that's the plan. I think we can do this the simple way first, and then with this as a backup if we need. Thank you.